In this lesson, we're going to go over the various properties that are used all throughout algebra, the properties of equality and congruence, and then at the end, we're going to finish by learning how to apply those properties in the context of geometry. So we have two categories of properties that we're going to discuss. The first one is the properties of equality. So the first property of equality that we're going to go through is called the addition property. And this says that if A equals B and C equals D, then A plus C equals B plus D. And this is it looks kind of weird, but if we use an actual example, it makes it a little more easy to understand. If we use an example from algebra, x minus 3 equals 7, we know how to solve this by simply adding 3 to both sides. Well, we can add 3 to both sides to get x equals 10 because of the addition property. So the addition property simply says that we can add the same thing to both sides. Likewise, we have the subtraction property, and this math notation is kind of confusing, so let's look at an actual example. An actual example would be if we have x plus 3 equals 7, we can solve this by subtracting 3 from both sides. When you subtract 3 from both sides, we have x equals, and that should be 4, not 10. And the reason we can do that is because of that subtraction property that says we can subtract the same thing from both sides without changing the equation. The third property is similar, and that is the multiplication property. This says that if A equals B, then we can multiply both sides by some number, and that's going to be represented by the letter C. So an actual example of this would be if we had x over 4 equals 5. Because we're dividing by 4, x divided by 4, to solve this, we'd have to multiply both sides by 4. So when you multiply both sides by 4, we'd get x equals 20. But we can do that because of the multiplication property, which says that we can multiply both sides of the equation by the same number. And likewise, we have the division property. The division property says that if we have A equaling B, and assuming that C is not 0, then we can divide both sides of the equation by some number C. Using an actual example, if we had 5x equals 20, we'd solve this by dividing both sides by 5. When you do that, you have x equals 4. But the reason we can do that is because of the division property, which says that I am allowed to divide both sides of an equation by the same number. The fifth property of equality is what's called the substitution property. And this says that if A equals B, then either A or B can be substituted for the other in any equation. So for example, if we were told that 2x minus y equals 12 and y equals 5x, then notice here this y, it's the same thing as 5x, as stated over here. I can replace this y with the 5x. I can substitute a 5x in for the y. So instead of 2x minus y, I have 2x minus 5x. And then I can solve this, and I get negative 3x equals 12, and then divide both sides by negative 3 to get x equals negative 4. So that would be the substitution property that says I can substitute that 5x in place of y. The sixth property of equality is what's called the reflexive property. And this simply says that something is equal to itself. So A equals A, B equals B, or 4 equals 4. So anything is equal to itself. The seventh property of equality is the symmetric property. And this property says that if A equals B, then B equals A. So basically, I can switch the order that the equation is written. So another example would be if 4 equals x, then x would be 4. So we can switch the order, and it does not change the equation. The eighth property is called the transitive property. And this says that if A equals B and B equals C, then A equals C. So an example of this one would be if x equals 3 and x is also equal to y, then 3 and y must also be equal. And notice for this one, maybe a way to remember, transitive looks kind of like the word train. When you think of a train, you have the different cabooses that are connected to each other, and that's kind of what we have here. We have A connected to B, B is connected to C, so A and C are going to be connected as well. They're going to be equal. And that's the idea behind the transitive property. So to recap everything we see here, there are 8 properties of equality. Make sure that you know how to use each of these. Okay, we'll move on now to the next category of properties, and that is the properties of congruence. And a lot of these are similar to the properties of equality. The main difference is instead of an equal sign, you're going to have a congruent sign. So reflexive property, same thing as with equality, except the only difference is the congruent sign. So AB is congruent to AB. Okay, segment is congruent to itself. Okay, that's the reflexive property. So another example with angles would be angle C is congruent to angle C. By the way, side note, notice the notation above. This means that you're dealing with segment AB. Remember, in a previous lesson, we learned that segments, shapes, are congruent, whereas the length or the distance, because it's a number, would be equal. So the length or measure is equal, and the shape itself is congruent. And here we have angle C, that's a shape, is congruent to itself, another shape. Shapes are congruent, whereas the measure of those shapes, measures of those angles, would be equal. Second property is the symmetric property, where it says if AB is congruent to CD, then CD would be congruent to AB. I can change the order of the congruent sign. Also with angles, if angle E is congruent to angle F, then angle F is congruent to angle E. We're just switching the order around the congruent sign. Number 3, transitive property, same as with equality. The only difference is with the congruent sign. So if AB is congruent to CD, CD is congruent to EF, therefore AB and EF have to be congruent. And with angles, same idea. Angle E is congruent to angle F is congruent to angle G. Therefore, angle E must be congruent to angle G. That is the transitive property. So those 3 properties are the only 3 properties of congruence that we're going to discuss. And the last property would probably fall more under, I guess, properties of algebra, but it's kind of its own category, and that's called the distributive property. The distributive property we've seen in algebra, but we'll show it again here, and that says that if you have some number, A, times 2 things added or subtracted in parentheses, then I take A times that first value, so A times B, then plus A times the second value, so A times C. And that is the distributive property. So for example, if we had 4 times parentheses x plus 2, I would distribute. I would take 4 times x to get 4x, and 4 times 2 to get 8. So I'd have 4x plus 8. Now that we have learned the many different properties in geometry, I'd like to now use the last part of this lesson to discuss a very important topic. However, this topic is one that most geometry students find to be the worst part about the class, and that is the topic of proofs. Now, what is a proof, first of all? Well, a proof is starting with a given statement and using logic to come to a conclusion. Now, why is this important? Well, it's important in every aspect of life. Whether or not you do anything math related, that is besides the point. You can use proofs for debate, whether you'd be debating in politics or just talking to a friend. You need to have logical progression of thought to draw people to a particular conclusion. And it could be very important issues, maybe issues of abortion or drugs or alcohol usage or whatever. Okay, there is logic that is needed to prove your case. And you cannot just make statements without backing it up with logical steps. And that is what we're going to do now at this time, is introduce you to that idea of proofs. And now obviously these proofs will be in the context of geometry. However, the concepts that we will discuss can be adapted to any aspect of life, not just in geometry. So don't get bogged down necessarily with, why are we needing to know that this angle is equal to this angle? So yes, that particular proof may not be coming up in everyday life per se, but the logical progression of thought is fundamental for everyday life. Now, with that being said, I'm going to show you 3 examples here at the end of this lesson. The first example is in the context of algebra. The second example is in the context of segments. And the third example is in the context of angles. So looking at example 1, you are given a statement, 3x equals 6 minus 1/3 x. And now we've never really thought of algebra as being a set of statements in a proof. However, that's essentially what you're doing when you solve an equation. You are using logical steps to get from point A to get to point B. In this case, we're trying to go from this equation and trying to conclude that x equals something. Now, for every statement that you're going to give, you need a reason. You cannot just make a statement without backing it up with a reason. So this first initial statement is going to be just given to you. So the reason is going to be because it is given. So for every proof, you need a statements column and a reasons column. So the first statement is typically always going to be your given information. So the reason should typically always be given for that first step. Now the second step can be multiple things. There's not one set way to solve an equation, but maybe a good first step is to get rid of that fraction, the negative 1/3. Most people do not like fractions, so if we can get rid of the fraction somehow, that would make this equation a little bit easier. So how do we get rid of a fraction? Well, what I can do is I can multiply the equation by something. And when I multiply, I want to get the fraction to be gone. So if I multiply everything by 3, I'm going to have 9x, and then 6 times 3 is 18, and then 1/3 times 3, 1/3 of 3 would just be 1. So when I multiply this by a 3, the negative 1/3 by a 3, this now becomes negative 1x. So that would be a good next step. But remember, I need a reason for doing that. I cannot just make a statement without giving a reason. Well, what is the reason? Well, I multiplied both sides of the equation by the same number. I multiplied by a 3. And what property says I can multiply both sides by the same thing? Well, that is simply your multiplication property. Your multiplication property says that I can multiply both sides of the equation by the same number. So that would be the reason for step 2. Now we need to get the x's together on the same side. So how do we do that? Well, if I were to add x to both sides, this brings the negative x over to the left side. This will cancel. I now have 9x plus 1x, which gives me 10x. So that is a good next step. But for every step, we need a reason. So what is the reason that I can add the same thing to both sides? Well, the property that says that I can do that is called the addition property. The addition property says I can add the same thing to both sides of an equation. So that would be your reason for that third step. And then lastly, to finish this equation, I need to get rid of the 10 by dividing both sides by 10. When I divide both sides by 10, I now have x equals 18 over 10, which can reduce to give you 9 over 5. Now once again, I need a reason for doing that. Well, I divided the same thing on both sides. The property that says that I can do that is your division property. So that would be the reason for step 4. Now let's look at 2 more examples. The next one is in the context of line segments. Here you're given that AC and BD intersect at point E so that DE is equal to EC and AE is equal to BE. And you're trying to prove that BD equals AC. Now when you have all the information like that, it's helpful to draw a picture, and it's not always given to you. So if it's not given to you, draw yourself a picture. And here we see that AC, this segment here, and BD, this segment, intersect right here at this point, point E. And when it does, DE, so the segment from D to E, is equal to the segment from E to C. And then AE, so the segment from A to E, is equal to the segment from B to E. Now notice the line going through. That is a way to show that segments are congruent. So we see that this segment AE and the segment BE, they both have one line going through it. Well, that means that those two segments with just those one line through it are going to be the same measure. And then DE and EC have 2 lines through it, which mean that those two are the same measure. So that's just a way to show quickly on a picture that something is congruent, that something has the same measure. And then we're trying to prove that BD is equal to AC. So this entire segment is equal to the segment AC. Now when you do a proof, you need 2 columns. You need the statements column and the reasons column. And the first statement is going to typically be your given information. So it is given that DE is equal to EC and AE equals BE. So that would be your first given statement. And the reason is because it is given. So that first step should never really be missed, because you should have in there somewhere this given information right here. The other part, saying that it intersects at point E, that really does not help in the proof. It's just giving information about the picture. So now from here, we're trying to get to the point that BD equals AC. And sometimes it's helpful to kind of think through conceptually, what are you trying to figure out? And maybe even using actual numbers to help you figure it out. So for example, if we use actual numbers, DE, if that is equal to 6, and then EC would be the same, so we'll say that's 6, and it could be any units, it could be 6 inches, 6 feet, it could be anything. And then EB, let's say, is 4 inches, and then AE is the same measure, which is also 4 inches. So we're trying to prove that BD, this entire length, is equal to AC, which would make sense, right? If we take 4 plus 6, the entire length would be 10. And then 4 plus 6 for the other segment would also be 10. So in our minds that makes sense, but we need to know how to lay that out step by step. How can we prove that that is true? So right now, we only know that the parts of the segments are equal. But we need to get to the point where we have the entire segment DB and the entire segment AC equal to each other. Well, how can I do that? Well, if I add together the smaller portions, they would equal the bigger portion. So for example, if I were to add DE plus EB together, and then add AE and EC together, those would be equal measures, right? If we had 6 plus 4, that equals 6 plus 4. So that would be a good next step, is we can say that if we take DE plus EB together, that's going to equal the measure of AE plus EC. Now we need a reason for that. What property do we know that says that we can add those together? Well, notice right here, we start with this statement, DE and EC. Those are equal. And then AE is equal to BE. So if I were to add to DE the EB right here, so if I were to add this one and this one together, then that's going to be the same thing as adding this one and this one together. The reason is because we're adding the same thing. If I add BE to DE, that's the same thing as adding AE to EC, because AE and BE are the same. So I can add AE to the one and then BE to the other, and that's going to be the same thing because those parts are equal. So what I'm doing is I'm essentially adding the same thing to both sides. So the property that says that I can add the same thing to both sides and keep the equation equal is the addition property. So that would be the reason for step 2. Now we're almost done. Step 3 is we need to get these smaller segments put together to equal the bigger segment of BD and AC. So notice if I add together DE plus EB, if you put those together, I get the bigger segment DB. So if I take DE plus BE, that's going to be the same thing as BD. We're just adding the two smaller parts to equal the bigger part. Same thing for AE and EC. If I add AE and EC together, that's going to be equal the entire measure of AC. Now the property that says I can do that would be your segment addition postulate. So it's a postulate, not a property in this case. And we can do that because the segment addition postulate says I can add the two smaller segments together to equal the bigger segment. And now we're almost done. The last step is that we can conclude that BD would equal AC. Now this one is not as obvious for a lot of people, but the reason that says we can do that is if we were to take a look at this initial statement, DE plus BE. And then right here, we see that DE plus BE is equal to BD. Those are the same thing. So in place of DE plus BE, I'm going to put in BD, because those are the same thing. So I'm putting in a BD, which is where we get this right there, that BD. And then the AE plus EC, we said right here it's equal to the bigger segment AC. So in place of AE plus EC, I'm replacing that with AC. And that's what we get right there. So what we are doing is we are substituting BD and AC in place of DE plus BE equals AE plus EC. So we are substituting, and that would be your reason. It is the substitution property. And we are finished with the proof. We started with the initial statement that was given to us. We put them together to get the entire segment BD equaling AC, and we are finished with the proof. Notice the last step is always what you're trying to prove. You're trying to prove something to be true, so your last statement should be what you're trying to prove. And the first statement is always going to be your given, typically. Let's look at one more example. And in this example, we are dealing with angles. We are given that the measure of angle ABD is equal to the measure of angle CBE. And we are trying to prove that measure of angle 1 equals the measure of angle 3. So your first statement and your first reason will almost always be your given statement. So if we start with the given statement, measure of angle ABD equals the measure of angle CBE, the reason would be because it is given. Now your last statement in the proof is going to be measure of angle 1 equals measure of angle 3. So we need to somehow get from this given statement to measure of angle 1 equaling measure of angle 3. So the question is, how do we do that? Well, if we look, we see that we're starting with the bigger angle, but we somehow need to get to the point that the small angle, angle 1, is congruent to angle 3. So what I can do is I can break apart the bigger angle into a sum of the two smaller angles. So this measure of angle ABD, if you look at that angle right here, notice if you add angle 1 and angle 2 together, we're going to get this bigger angle. So I can just say that. I can say that the measure of angle 1 plus measure of angle 2 would equal the bigger angle, measure of angle ABD. And then same thing for CBE. This angle right here, CBE, right, from C to B to E, this angle is made up of the two smaller angles, angle 2 and angle 3. So if I add angle 2 and angle 3 together, I'm going to get the bigger angle. So I can say both of those in the same step because I'm really saying the same thing. I'm just saying that I can split apart the angles into two smaller angles. Now what is the reason for this one? Well, this would be your angle addition postulate, because that postulate says that I can add two small angles together to equal the bigger angle. Now for the next step, I, at the end, want to get to the point where I have, just angle 1 and angle 3 together. Measure of angle 1 equaling measure of angle 3. So a good next step would be somehow putting these angle 1, angle 2, and angle 3 together. I need to get this and this somehow in the same equation. Well, notice the original statement. We have measure of angle ABD and measure of angle CBE. Well, I can replace measure of angle ABD right there in place of measure of angle 1 plus measure of angle 2, because we said right here in step 2 those are the same. So in place of measure of ABD, I'm going to put in angle 1 plus angle 2. And then for measure of angle CBE, I can replace that with this statement, because we just said in step 2 those are the same thing. CBE is equal to angle 2 plus angle 3. So I'm going to put that right there. And now what I'm going to have is going to be the measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. And the reason for that is because I'm substituting. I am substituting these measure of the angles 1 and 2 in place for ABD, and the measures of angle 2 and 3 in place of angle CBE. Now we have an equation, and we just want to get angle 1 and angle 3 by itself. So if I can just get rid of this measure of angle 2, then I'm good. Well, just think through algebra at this point. If you subtract measure of angle 2 from both sides, these will cancel, and I'm left with just measure of angle 1 equaling the measure of angle 3. Now a little side note, before you just start subtracting something, you cannot subtract something unless it's a number. So like if you're subtracting 30 or 40 or whatever, or if it's not a number, such as in this case, you have measure of angle 2, what I need to do is just show or state that measure of angle 2 is equal to itself first. So we are just going to say measure of angle 2 equals measure of angle 2. And that's going to be the reflexive property. And now once I have that, then I can subtract the measure of angle 2 from both sides. And when I do that, these will cancel. And now I have measure of angle 1 equaling measure of angle 3. And the reason for that last step is because of the subtraction property. I'm subtracting the same thing from both sides. And that concludes the proof. We took our original statement and ended up with what we're trying to prove, where measure of angle 1 equals measure of angle 3. So we are finished with proofs for this lesson, and in the future we'll get more into proofs and discuss them in more detail. But at this time we are done with the lesson for today, so we will see you next time.